This is cathode ray oscilloscope, and we'll show the functioning of the cathode ray oscilloscope. You can see there are two knobs are there. This is the knob for voltage per division for channel number 1. This is the voltage per division again for channel number 2. This is the common second for second per division. That means these are the two. This is the voltage, and this is for channel number 1. This is for channel number 2, and this is the common for both. This time division is common for both. And this you can change the position for the channel number 1. This is you can change the position of the waveform for the channel number 2, and this is the horizontal you can move. And you can see this is the intensity. You can change the intensity. You can focusing. You can do it this, and these are the main things. And now I am coming to the switch on that switching on. You can see it is getting switching. After switching on, I just put a probe here. You can see the channel number 1 and channel number 2 is both are displaying, and now I just channel number 2 I make it off, and just channel number 1 is remaining, and waveforms of channel number 1, and therefore now I am connecting to the channel number 1, and then I connect the probe in the projection. Here you can see a projection here. I just connect. You can see there is a square type waveform is coming here. I told you this. You can position it ups and downs. You can see, and you can see that you can position it. Now you can see it is not very. You can peak to peak. If I want to measure to peak ups and downs, you can if it is not very stable, it is like this unstable, you can make it in this. You can see there is a knob. It is written as level. You can make it a fixed. After that you can position it properly, and you can see that now it is very stable. You can measure how many divisions it is taking from peak to peak, from low to high. It is almost 2.5. That means 2.5 divisions. Now after seeing that how many divisions, you can see the divisions here. After seeing that, you can see where it is been set, my voltage per division, where my knob is been set. You can see the knob here. It is been set into 0.2. That means 0.2 multiplied by 2.5. It is coming as 0.5 volt. Therefore, peak in this case, peak to peak is 0.5 volt. And if you want to see the frequency here, you can go to the time divisions, and again you have to see how many horizontally how many division is taking. Now I'll adjust it with this. Therefore you can see that I can move it horizontally. You can see that negative part, low is in 1 division and high is 1 division. Therefore the complete cycle is taking 2 divisions. Therefore your time division, while it has been set into the time division, you can see it is set into the 0.5 second, 0.5 millisecond per divisions. That means horizontal 1 division is 0.5 millisecond per division, and I have to multiply it by 2, because in one cycle there are negative and positive part is there, low and high. I have to multiply it by 2. Therefore it is coming as 1 millisecond. 1 millisecond time period is coming as 1 millisecond, 0.5 into 2, and therefore frequency will be 1 kilohertz. In that way, from a particular waveforms, you can get the your vertical whatever you can find what is the voltage, and horizontally measuring the divisions, you can find what is the time period of that particular waveforms. And this is the things, and another few things is there. I can exactly in the similar way I can go for a channel number 2 also. I can show you the channel number 2 also here. And first I have to switch on the channel number 2. I am just switching on the channel number 2 here, CH2, and you can see another things appears, and then I just connect it here, channel number, this is the channel number 2. I can connect it here, and you can see here again channel number 2, and the red knob is connected to these projections, and we should get the waveforms. Now you can see it is very unstable then. You can make it stable by this. You can see that already I told this, the level is there. You can make it stable, and you can, now it appears fine. It is appearing fine. You can see that now it is appearing. Now it's a distinct one. You can make with the adjustment with this, with the levels, and you can see exactly in the similar way, whatever I described in the channel number 1. Here also it is a vertically it is a 2.5 peak to peak, and therefore here also it has been adjusted to 0.2, and therefore it is a 0.5 volt peak to peak, and here, and time division also 1, and it is 1 division and 1 division, 2 division multiplied by here also it is adjusted to 0.5, therefore 1 millisecond, and therefore here the frequency is 1 kilohertz, and therefore these are the main knobs here, whatever to be explained, and it is required for the operation for the experiment. And one thing is important, until and unless you get this type of a waveforms by connecting the red one to these projections, you should not proceed for an experiment, because until in that case your oscilloscope CRO is not properly adjusted. After properly adjusting the CRO, you proceed with your experiment.